welcome to the last video of naming and drawing organic molecules. And this is worksheet 2, and it's the hardest you'll get in honours chemistry. In fact, the questions we look at today, you'd probably never see them in an honours chemistry test. They're more preparation for AP. But if you do understand these ones, and if you can name them appropriately, then you've really got the idea. So we're just going to work on some of the questions that some people have indicated that gave them problems. Section 1 seemed to pass without comment, and it wasn't too difficult, I guess. Section 2 is just trying to draw an alkane in different ways to make isomers. It's section 2 that's given people a few problems. And the ones that have given most issues, according to the communications I've received, are the first two, because they're almost exactly the same molecule, but they have very, very different names. So let's, start with the first one. So we start by looking at the longest carbon chain, as we always do. 6, and there are no double bonds in the actual carbon chain. I know there's one there in the ketone group, but there's nothing to make it an alkene or an alkyne. So we start with hex an. And you'll notice I haven't yet added the E, and that's because we now have to decide what the suffix is. And the suffix, the very last bit of the name, depends on which of the functional groups we name the molecule after. And here is the ketone, and here is an alcohol group. There's no others. So here's the decision. Is this name going to end in ol for the alcohol or one for the ketone? And it's going to be the ketone, because the double bond oxygens, whether it's an aldehyde or a ketone, always take precedence over the simpler ones like hydroxyl, or if there's a halogen, or if there's a methyl or an ethyl attached to it. In fact, those last ones, they're never the suffixes. They always go at the beginning. So we did have to make a decision here, and we prioritize the one over the ol. So it's hexan one. And you'll notice I've left a gap between hexan and one, and that's to determine where it is. So we can count from this side, 1, 2, 3, 4, where it's attached to the 4th carbon, but we don't, because we count from here, and it's one lower. And we choose the lower of the numbers. So it's hexan 3 one. And we started from here. And so now we have a look at that. So attached to carbon 1, there's a hydroxyl group. And so it's simply 1-hydroxy hexan 3 one. All right? Fairly simple. Now let's go on to the next one, which is pretty well exactly the same molecule, except it's got a double bond here. And so now that takes precedence over the functional groups. It's now an ene, and that's our suffix. So once again, 1, 2, 3, 4, 5, 6. It's hex ene, and once again I've left a gap between the number part of the word and the suffix, indicating that's an alkene and has a double bond. And once again we can count from here, 1, 2, 3, 4, or 1, 2. And so the smallest number of carbon that the double bond is attached to is number 2. So it's hex 2 ene. And that means we've started counting from this end. So that's already quite a radical difference between the way we named this molecule, 1-hydroxyhexan 3 one, and this one, whatever this may be when we finish naming it. So what we have to do next is name the functional groups and say where they are. And so we've got the same functional groups. We've got our hydroxy there, which is now attached to carbon 6, and we've got our ketone here, which is attached to carbon 4. But we can't now call it one. We have to call it 4-oxo hex 2 ene. And now we've got this one, and it's our 6-hydroxy 4-oxo hex 2 ene. So almost the same molecule, but radically different naming systems, simply because the double bond, making it an alkene, takes precedence, makes us use that as the suffix, and that pushes all the other ones back in the queue and leads us to this rather strange little bit here, oxo, to say that there is an oxygen double bonded to carbon 4. It's clear when you look at it, but it's probably not a thing you knew how to do before. All right, let's move on to the third one, which is quite close to the end of section 2, and it's got an amino group in it. We notice that first. And it's also got 2 hydroxyl groups, and it's got an one there, a ketone. So let's have a look at it. 1, 2, 3, 4. It's a bute, and it's a butan because it's got no double bonds in the actual carbon chain. It's not an alkene, it's not an alkyne. And then we have a look at the things here. Which one takes precedence to give us the suffix? And again, it's the double bond oxygen. That takes precedence over the amino group or the 2 hydroxyl groups. So let's have a look at this one. Is it attached to 1, 2, 3 or 1, 2? Clearly it's attached to the second one. And now we've got to label our carbons accordingly. So let's have a look at the hydroxyl groups. There's 2 of them, so it's dihydroxy. And they're both on the 3rd carbon. So 3,3, dihydroxybutane 2-one. But wait, there's more. And that's our amino group here, which is attached to carbon 4. So 4 amino 3,3 dihydroxy butane 2-one. To be honest, it's easier to take this name and construct the diagram from that, but you probably need to do it the other way around, although it's doubtful you'll ever get one this complex. And now the last one we're going through today has this hex ring here, but it's an unusual hex ring. It's got this circle in it, and that means it's got some double bonds in there, but they circulate, they move. The electrons that make up those covalent bonds that are double bonds move from carbon to carbon or between carbons. And that means we can't actually write double bond here, double bond here, double bond here, like we did with some of the other groups like the phenol group. But we just call it a benzene. And that's something that's kind of basic to the aromatic compounds that we haven't yet studied. But essentially, this is benzene. Where on earth am I going to write this? Here, I guess. So we start with a benzene because that's the basic format of it. That's the most amazing thing, the most characteristic thing about it, because it's the basis of the whole molecule. And we call it benzene. And then we have to look at the functional groups. Hydroxy, fluoro, methyl, and ethyl. Okay, so let's see. First thing we do is decide where we're going to do the numbering, because in the cyclics, remember, we have to number where the functional groups are. These 2 we don't do. We now look at the most complex of these, which is this, and so we label 1. And we label it round 2, the next most complex that isn't just a hydrocarbon, and then we finish off with the hydrocarbons. We label clockwise, which is the normal way of doing it. And so, let's have a look. 1 hydroxy, 3 fluoro, 4 methyl, oh, this is getting ugly, and 6 ethyl. Whoops. And so, what you do to label these ones, you start with the benzene, then you work out where to start numbering the carbons, and they're from the most complex of the functional groups that's not just a hydrocarbon, and this one has 2 atoms in it and this one has 1, and then you label clockwise around there. So it ends up being benzene, 1 hydroxy, 3 fluoro, 4 methyl, 6 ethyl. And they don't get any harder than that, at least for this year. Once you get into AP and beyond, then you'll discover complexities that people are still naming. But for now, that's all you have to do. All right, good luck in constructing those worksheets and completing the answers. And yeah, April 3rd deadline for those. Good luck.